Here's an idea what it's like outside in my yard and driveway. If you like snow, here it is. I'd say come and get it. Hear the sound of other people shoveling. It's gonna snow. Okay, so I think it's time to try the FM alignment side of things, and I have to admit I'm not as skilled or knowledgeable about doing FM alignments. I tend to stay away from them, in fact. And a lot of the equipment I work on doesn't have a FM receiver anyway, and when it does, it's usually working well enough, I just leave it alone. But this one, you can see from all the capacitors here on my bench, I'm a little bit concerned about, and the reason is, although I shot this on video, I'm not sure I'm going to post it. I started the FM alignment following the procedure according to the guide down here, and I ended up doing something that I should never do, and that is I turned one of the tuning, actually what it is, it's the primary side of the FM detector coil transformer, not sure what to call it. What do they call it here? Ratio detector. Okay, so the primary side of the coil that's involved with that. And I have my indicating meter connected in the way it's supposed to be connected. And I got a really weird result. I ended up turning it all the way to its extreme, watching this meter move. And I thought, wow, this can't be the case. I mean, it can't be that far out of whack. And of course, I turned it 8 revolutions by then. I tried to crank it back, but I couldn't find the sweet spot again. So in a little bit of a panic, I just turned the radio on, tuned in the station, and began turning it like that. And the whole time I'm telling myself, "No, Jim, this is dumb. You're in that stupid zone here." So what I've done since then, and maybe I will post that anyway. We'll see. So what I've done in the meantime is I've studied up on a ratio detector, some interesting videos on YouTube about it, and I've read up on it, and somehow, you know, I've got like this 85% grip on how it works. I just can't quite absorb the last 15%, which happens to me all the time. It's a pretty normal thing. The last 15% kind of drives me nuts. Now, just to add more complication to it, let me take it out here. These capacitors. Again, you may not be able to see this clearly on camera, but here's the ratio detector. It's all this part here. Okay, and some interesting, and it works on the basis of a phase relationship between two, let's call it versions of the 10.7 IF signal that's coming out of here. Now, it's not 10.7 solid. This is an FM receiver, which means frequency modulation, which means the frequency is varying, and that's where the intelligence is hidden in the variation of the frequency. So the detector is trying to extract the audio out of that, as all detectors do, and it involves phase shift and some other things that are going on to create a audio signal based on what's going on with this varying 10.7 signal that's coming out of the IFs here. So one of the key components is a load resistor and a capacitor, and you can see them over here. And it's a fairly large capacitor, as capacitors go in radios. It's a 3.2 microfarad electrolytic capacitor. I've seen this kind of circuitry in radios before. You can always spot this capacitor sitting there. And 3.2 is a bit of an odd number. And the reason I have all these capacitors all over my bench is I was looking for a replacement. I think I may have found one here for it. Now, why would I want to replace it? First, the experience I had with trying to adjust the primary coil suggests there's something amiss in the radio. But you know, lack of experience here. It may just indicate my own lack of experience. Number two, let's take a close look at the capacitor itself. And you know, you can be the judge and of the condition of it. So I'll just swing my camera down here. I noticed this very early on when I was working on this. I had an eye on it the whole time, but based on no objective reason to do anything about it, I've left it as is. Now there it is. You see a blurry look at it. Let me just get rid of the blur here. There it is. A little electrolytic capacitor. And what's caught my attention is the top of it. Okay, let's look down on it. Look at the top of it. Okay, now that's not store-bought condition. That material there that is squeezed out the top indicates to me there's something fishy going on with this capacitor. Now what I don't know is, you know, is there a so what to this? It's supposed to be 3.2. What if it's 1.5? What if it's got, you know, its capacity has dropped? What's that do to the functioning of the ratio detector? I don't know. That's part of the 15% I don't get. So, incidentally, if you're looking at this resistor and wondering what's going on, its actual color is orange, 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 quite clear in my eyeballs, but the camera's not doing it justice. I think I should probably replace it. It's 3.2. How critical is the size? Because I can't find a 3.2 capacitor in my collection here. But what I do have is one of these two here. This one here is a 4 microfarad, 50 volts, so it's perfect. Appears to be in perfectly good shape. I really don't have any reason to doubt this. But it's a little bigger. It's a 4. You know, I could clip this in parallel, but then it would be 4 plus 2 would be 6. It'd be double the size. Usually, if you're doubling things, you're starting to get out of the range. You know what? There was a note. Come to think of it, there was a note on the schematic that talked about which components were critical in size. So I'm going to take a moment and just try to find that note and see if there isn't some actual direct information about the need to maintain precision on this capacitor. Okay, it just took me a moment to find the note. It's right in here under condensers. And they have a little bit of information about the 4 kinds of capacitors you find in here: tubular, electrolytic, ceramic, and mica. So for instance, I know you can't read this. The print is so small I can barely read it. Condensers have the letter T in, I'm sorry, tubular capacitors have a letter T, followed by the capacitance in microfarads and the DC working voltage. So they're just telling you how they've arranged the information on the page here. Electrolytic's the same thing. Electrolytic followed by capacitance in millifarad and DC working volts. Ceramic, this is the note that I remember. Ceramic followed by capacitance in microfarads and tolerance if critical. Same thing for mica. Tolerance if critical. So that's kind of curious. It looks like the very, very small capacitors can be more critical about their actual value than these bigger guys. Maybe that makes a lot of sense. I don't know. So electrolytic, what to do here. I have no way of measuring these to verify their size or function. I run the risk here. If I replace the 3.2 with a 4, I'm doing something in here that's not intentional. I'm going to guess the most likely thing is change the tonal quality of the audio that comes out of it. The audio actually comes out. Let me hold this a little bit better here. Let me get a look at this. Tricky to light this stuff. So the 10.7 signal is going through this last tube, the 1286. And the output is fed through this primary coil right here. The secondary coil is over here. And the secondary coil, though it's hard to figure out by looking at the lines here, the output of the secondary coil is fed through this double diode. It's a little like a power supply situation, except these diodes are turned in the same direction, which means they both conduct and then neither conduct. Kind of a curious thing, but that's what sets up the voltage down here across the capacitor in question. The audio is actually pulled out, excuse me, out of a center tap on the secondary, and it runs through this other coil. And this coil is coupled to the primary, but it's not a tuned coil. These two are tuned, I guess, to 10.7, so they resonate that way. Well, I hope this is clear enough for you. Maybe not. So the audio comes down here and out. You know what? I had another one of those. I woke up in the morning and realized, I just remembered it now, and realized something about this receiver that is blatantly obvious once you hear it, but thanks to the marketing people, is not so obvious. Let me show you here. Okay, a small aside. Here's the front of the radio, and down at the bottom it says stereophonic, high fidelity. So when I see stereophonic, I think stereo FM. Guess what? This is a mono FM. The audio comes out here and it's just fed off to the amplifier, where both channels must receive the signal from here. Both channels playing exactly the same thing. So you go in the store to buy this thing and you see that big stereophonic thing in 1958. You'd have to ask questions to find out that the FM receiver is not stereo. And you know, that might have been a really new thing anyway. It could be that FM stations were just getting into stereo around that time. I really don't know the history of the situation. So just in talking this through, and thanks so much for listening to me talk my way through it, I think my best move is to replace this capacitor, try not to damage it in case I have to put it back in. You know, I could even just disconnect one lead, bend it aside, put in the new one, and then see what we get out of this thing. Yeah, you know what? That's the way to do it. Pull one lead off, put the other capacitor in its place. And you know, it's kind of the same thing I did with that Japanese radio. If you watch the videos on the Japanese radio, right at the end I'm working on another ratio detector. And I did change the capacitor on that one, and I didn't get my shorts in a knot over it. I just went ahead and did it. I can't remember now. I think I had an exact size replacement, so I wasn't too concerned about it. So I think my best move is to make that guy go away. Looks a little packed in there, isn't it? Take off this clip lead here. It is definitely a little packed in that area. Let me move the capacitor around a little bit. We can kind of, yeah, even that's easier said than done. Pretty sure I see the lead to it down under here. Yikes. I don't like moving any of these components, he says as he moves them. You just never know what is positionally critical. That's another thing that became very obvious in that Japanese radio when I wiggled the wire a little bit, and holy smokes, what a difference. So gotta be the easiest thing is to nip the top wire and then pull it away. You can see that other capacitor I replaced right next to it. Yeah, this stuff was rolling through my head while I was doing that, but I wasn't saying anything about it. Now, what's this big ceramic guy doing there? He's going to ground, and the lead bridge is right over top of the capacitor, making things a little bit inconvenient, but I should be able to pull that capacitor out to this clear area here. Straighten out the lower lead when I do that, and even make it accessible for the new capacitor. That's my plan. Gonna do that. Guess in the worst case, you know, if this leads to a problem, I'll just have to go and try and buy a properly sized. Let me just gotta move this over this way. That's scary. Better do this by direct vision. Oop. Oop. More than once I've reached into a radio like this and cut the wrong thing or cut two things by accident. I really want to preserve as much of that lead as possible. Lead on the capacitor. Keep it on the capacitor. And if I had some finer cutting tools, I'd probably be better off to get in there. That's about as good as I'm going to get, I think. The deed is done. Let's see about getting it out of there, because it's kind of trapped by that capacitor. Maybe I won't be able to swing it right out. Oh yeah, out it comes. Now, some of you who are watching my videos have real radio engineering experience. It's obvious from your comments and that, so if you want to say something about this, criticality of the component size, it's kind of caught there, isn't it? Come on. Well, by all means, I'd like to hear about it. Oh. Here, let me just back this camera right off here. There. Hey, what's that little bump on there? Let's go back in for a little closer look. Yeah, I think it's just some junk on the outside of it. I don't think it amounts to anything more than that. Work in the replacement here. It's a 4. looks a little big when I have it up close to the camera, doesn't it? Now, where's the positive on this? I need some proof positive. Which end is positive before I move it up? Probably this leaky looking end here is probably the positive end. It's got the shape you commonly see at the positive end. Let's see. Now the end that's still connected there. It is connected to, I think it's connected to this resistor, which is 3 orange bands on it. And it makes it 33K. Okay, so let me just take a look at the circuit diagram here for a minute, because I think it was 33K that it was right across. $33K. Oh yeah, this doesn't help me either. Is it positive is to... Well, one end goes to a terminal on a 6AL5. The other end goes to all this schmozzle here. But I think the tricky thing is there's a open terminal on that 12AL5 and it's being used. Excuse me, as a connection point. That makes the resistor look like it's connected both ends onto the tube. You don't want to get this wrong. Looks like it's connected to, well, there's pins sticking through where it's connected. This isn't helping me one bit. Okay, another approach. I'm traveling down a road to nowhere here. Let's just get a better look at the capacitor. I mean, I think probably the chance of replacing it, introducing a problem, is really quite small. Oh, I see the positive and the negative. Okay, no question, no question. Feeling more comfortable now. Oh, I gotta fish this thing in there, holy smokes. Smokes is right. Yeah. This is not going to be easy. Make sure I got this one straight on which end is positive. Even this capacitor is not fessing up here. Well, I don't think there's any doubt. That end's the negative end. This end is the positive end. I'd be stunned if I got that wrong, so we'll... move these parts around. Oh boy, that's going to be tough getting the soldering iron in there. So there's the terminal. What if I just strap it right across the 33K resistor? Because that's not quite right. Oh, haha. There, I see two terminals are tied by a little piece of wire. Massive amount of stuff connected there. So yeah, right across the 33 should be a satisfactory way to connect this capacitor. Now the original one was right down against the chassis, but I don't think there's too much need to worry about that. So I can just kind of bolt it right on there, like that. The other thing too is that if this doesn't work, I have to remove it. So I don't want to get, too overboard with. I'll spend 6 hours getting this into place, only to have to remove it after. Again, I just don't think that's what's going to happen. Too much lead wire there, that's for sure. That's definitely the negative end. It's a little close to the component itself. If I can apply the solder, it's going to heat the resistor up quite a bit. Ah, darn it, I got it too close, too close. I'm too short of the lead here. I think I can slide it down a bit. Yeah, that's the way. There. Now, you know what? Maybe I'm going to solder that right in that spot there. That would be a good move at this point. Next good move would be to spot my solder. Here it is. Wow. Did I get that? I did. Fantastic. I'll just kind of bend it around like this. Wow, I didn't leave much extra lead here. Oh. I am my own worst enemy sometimes. Very snowy day outside. I actually shot a little video, which may have been at the front of this one. I'm not sure what I'm going to do with it just yet. I may have put it at the front of the previous video to this one. But, give me an idea what it's like in Canada, at least here now. I mean, Canada's a huge country, right? So the weather is not the same everywhere, ever. Canadians love their weather reports. Some radio channels that give a weather report every 15 minutes, every half hour. Beginning to be pretty tough to grab that little tiny tidbit. There we go. Okay. There. How's that look? Okay, it's in there. Just scoop up all these capacitors here. These are all just kind of random sized capacitors that I have acquired in various ways over the years. Some of them are recovered, but most of these are actually kind of new. Just stick them over here. Okay. Now, I think we can operate it. Just getting all the visual distractions out of the way here. Yeah, I'm sure we're good to go here. I better turn on my signal generator and get that ready to go. Going to need it shortly. And I have no other connections into the radio right now. Voltmeter, or signal generator, or anything. So it's just radio all by itself. Yeah, we're good. Here we go. Okay, starting once again on the light bulbs, as always. Volume is turned right down right now. I have the FM antenna input on the receiver is connected to my external antenna. That's turned up a little bit here. I hear nothing. We are on restricted power, so it takes a little while to actually get the tubes warmed up and currents flowing. Let's flip it to AM. Yeah. Okay, radio's working. Let's go back to FM. Oh yeah. Let me tune around a little bit here. Volume's about halfway.
People might have wearied of it, who knows?
So volume's up very high here.
The crusade against communism was drawn out, and was drawn out, and was drawn out, and was finally misidentified when applied to the third.
I'm only hearing one speaker.
Movements, when it was being analyzed by people who really didn't understand the text.
Yeah.
In simple ideological terms, there was a kind of realization that there'd been a mistake.
It's a little unexpected. Let me just check the AM side here again. I'm only hearing one channel. Come on. The happiness and joy is draining out of me. What gives? Just wiggling the tubes here. Well, you can hear the sound of the tube wiggling coming out of the quiet channel. They couldn't possibly have built this thing so only one channel operates on FM. Well, actually, it's on one channel on AM right now. Think, man, think. is working. Man, there's just too many ghosts and goblins in here. Okay, back to the FM side. Okay, it's definitely working out of both channels, but it is low. But you know, that's probably because I whacked the adjustment here all out.
I was interested in the larger world.
Yeah.
And
Because I've already whacked it out, I'm just going to go at it with this screwdriver. Oh, you know what? Hey, I'm on restricted power. Yes, thanks for yelling that at me. Here we go. Full power. Makes a big difference on FM often. Seems to push the tuning way over. I was doing this. There we are. One of the last things I said in the video where I started doing the FM, let's call the FM misalignment, I mumbled about it. I better just get a signal going into the radio and not rely on received radio stations. Okay, I don't want to put my middle screwdriver into the bottom because of all the contacts. So I'm going to go in the top here, just by ear.
there is something to be drawn there. There's something to be drawn from the situation that can be inspiriting. It's not that I'm saying, you know, the world has had it. Let me put it this way. You know, there is a...
Yeah, it could be a weak tube in the... could be this or this. Tube is weak. Could be any one of these. Could be weak. Producing a lower output. Looks like I'm going to have to go through another round of tube testing here to prove that. Either it is the case or isn't the case. Especially this 12BA6. It's probably the main gain tube.
And he says, thou art the thing itself. Unrequited man is no more than such a poor, thwart animal as thou art. No, I used to be a part-time actor. Every time I saw that scene, I was hooked because I was holding on to the air. Like my hands. I think that's one of the most beautiful.
Certainly seems to be a sweet spot tone-wise, like sound quality-wise. It's not what I would hope, though. I think I'm going to check the tubes next. Before I begin. Wait a minute, whoa, take that back. The AM radio also utilizes these same tubes. This one, anyway. I don't think it's utilizing this one. Certainly not utilizing this 12AT7 at the very front end. Okay, so let's go for the 12AT7 and the 1286. Might as well check the 12BA6 too. Okay, I'll get set up for some tube testing here.